Before we start, do you have any question or comment regarding last class or our exam? Okay. As you know that we scheduled our first meet on March 2nd, next week. Okay. Yeah, it is next week. So let me share my screen and show you some information. So today we'll talk about our one of our news session, or one of our news session is process and thread. We'll start the process and thread. In the syllabus, I changed little bit in just 1 point ups and down memory management. First, we complete the overview and also memory management. And today we are going to start the process and thread, and we'll discuss in details on it regarding these two important topic for operating system. Okay. And in our modules, you can see, if you go to our modules, then you can see we have total, so far we created 1, 2, 3 modules till 4 modules. This module will start now. This is for process and thread, and for, let me stop my video. Okay. This module actually created for this new module. It is for process and thread. It is not included for our mid one till module 3, especially introduction and process management system process. Okay, process management system till module 3. So from here, what's for preparation purposes, you need to study the PDF and PowerPoint. These are all PowerPoint slide. Even though this PDF, this is PowerPoint slide, this is also PDF PowerPoint slide. But you have to understand, you have to carefully read this additional PDF. Sorry, additional PowerPoint. This additional PowerPoint, and also all additional PowerPoints. Carefully read, and if you don't understand any topics, please look at this lecture video. Okay. So then you can take a good preparations for mid one. Okay, all questions are in MCQ or true or false. MCQ and true or false. Okay, true or false. You'll find this. There is total 30 question and 30 points. I gave you maybe total 60 minutes. So per question you'll get 2 minutes. I think this is good enough to complete a single questions. Okay, any questions? Okay. Okay, let's move our today's new chapter or new sections, which is process and thread. First, we'll talk about the thread process things, and then we will move forward the thread. Before we actually go for the process, process actually, to understand process and thread, we need to understand some additional things or feature from operating systems. Let's explore these things one by one. Okay, let me share my screen from my iPad. Okay, let me share the whiteboard so that I can type. Okay. Okay, hope you can see my whiteboard from here. So, okay. So today's topic is process and thread. Here, process and thread. So right now we'll talk about all regarding our process, and then our next, not next class, except after after some classes, we'll talk about the thread. These two are, there is two topics. There's two very important topics for operating system. One is called process, and another is called thread. So before we actually dive into the process, let's see some concept of operating system again. So first concept, we talk about the operating system and its kernel. What is the kernel of operating system? That things we actually must need to know before we explore the process and thread. Okay, so and next, as you know that operating system, our operating system is a big and complex program. There are kind of lots of function over there, F1, F2, and next F3 and Fn. Okay, there is millions of line over there. Also, it is very complex software, not a simple software. Okay, so this is operating system, and also you know that our RAM contains, what is the RAM actually load? RAMs load the processes. Also, operating system is a nothing but it is also a process, also a software and also a process. This should be loaded inside the RAM first from the starting point from the starting point of your computer's memory or RAM. Okay, operating should be loaded inside the RAM. Okay, so when you turn on computer, then your operating system also load inside the memory. Okay, let's say here is your operating system. So it should be always inside your operating systems, and this space actually cannot use for our other processes. This is space only for our operating system. Okay, this is called, so you know, this is called the OS space. OS space, and rest of the part of our computer's memory we can allocate for different processes. Okay, for different processes. Here we can allocate for different processes. Let's say P1, P2, P3, and whatever it is. Okay, P and let's say Pn. So this space is called user space. User space. Okay, here actually our process. The process means that the program you want to run. This process should take place inside the user spaces. Your process cannot actually touch any space from the OS space. Okay, from the OS memory space. Okay, from OS memory space. This is totally allocates for your operating systems. Okay, now let's see another concept. As you know that operating system is very big software, also big programs. From here, do you think that all functions or total operating system process, total operating system actually loaded inside the RAM? Yeah, if it is, this is the RAM. This is our operating systems, all processes in here. F1, F2, F3, F9, Fn, millions of say function in here. So this is very big process operating system. So do you think that whole operating system actually is loaded inside the RAM or memory? Actually, the answer is no. Most all modern operating systems, it doesn't load whole operating systems actually inside the memory or RAM. Okay, because it is very big programs. So it's if you loaded the whole operating system inside the RAM, it takes actually large space from your memory. Okay, from your computer memories. So what is actually loaded here? It's loaded here some important function. We can say there's some important, what does mean this important function? the functions that actually frequently used by our actually requires for our CPU, for our CPU, the function that's frequently used by our CPU, that function should be always, this function should be always inside the operating system, okay? Inside the operating system. Otherwise, actually, your computer actually may not function properly, okay? This function, this required function always should be inside the RAM. So if it is, if the total is operating system, from here we can say some part of this function is always inside your computer's memory, not all the operating systems. This part of this function or these important functions is called the OS kernel. Okay, OS kernel. This is very important topics. So if you go for interview some places regarding, if they ask for any operating system related question, they may ask this: what is the kernel of operating systems? Actually, it is some people may think that, okay, this is kind of same as the operating system, as well as same as operating system, but it is not exactly same. It is kind of the part of your operating system that actually always reside inside the RAM. Also, this is very important. It contains very important functionalities that are that actually CPU is frequently use these functionalities to perform, to actually to make ensure or smoothly run for your computer system, of your computer systems. Okay, what could be these important functions? For example, you already know about that if it is your computer CPU in operating system, there is one function called the short-term scheduler. If this is RAM, and here is disk. Let's say this is SDD, hard disk, SDD. From SDD to send, here is usually to send the process from SDD to RAM, which function is long-term scheduler. Long-term scheduler. And here actually when a process actually trying to get the CPU, then which function of operating system is scheduled for this process? It is actually, this is short-term scheduler. Schedule a process from the memory to CPU. Short-term scheduler. Scheduler. Okay. So these are very important. You see that when you run your computer, when you actually open several programs like MS Word, also some player, MS Office, MS PowerPoint or anything, Photoshop, anything you open in here. CPU, if it is multi-programming computer system, nowadays all of our system is multi-programming, multi-programmable OS, also multi-processing OS as well. So always short-term scheduler actually switching tasks from one task to another task, okay, to schedule a process for the CPU. So this is very important functions for a OS. So it should be the part of your kernel, okay. So this is very important function. This is one example. Also, long-term scheduler. Always you open a created process, it should be actually sent to the memory. This part is done by the long-term scheduler. This is very important functions. Also, file system management. Also, you know that's kind of memory management systems. Though these functionalities are known as these functionalities are very frequently used function as a part of our kernel. Operating system kernels. And another very important actually part for kernel is always maintained. This part is for all driver software. You know that when you add a new what is the driver software? When you actually add a new printers, you need to install your driver. So this driver also, if you add some another IO device like some gaming tools like joysticks and some other things, also it needs also some software driver software. So the keyboards, mouse, it has also some internal driver softwares, and this all driver software is a part of your kernel. Okay, is a part of our operating system's kernel. Okay, and some functionalities may need not actually frequently used by the CPU. This rest of this function is always resides in the disk when it needs. That actually that time it's loaded inside the OS space. Otherwise, it is inside the operating system. Okay. Okay. From here we can see that kernel is a part of OS that actually perform the important tasks for operating systems. Okay, so when you how long its kernel resides in your computer's memory, how long it resides, OS kernel, it resides when you turn on your computers, then all essential functionality loaded inside your computers. Means the kernel should be loaded inside your computer's memory. Okay, and stay there until turn off. So kernel part is always resides inside your computer's memory. Okay. Okay. So this is the very important topics for operating systems kernel. Okay, operating systems kernel. Okay, next let's explore some others concept. Concept is called, and that is called the user mode and kernel mode operations. Let's see what is the user mode and kernel mode operations. Okay, user mode and kernel mode operations. Okay, what is actually its meaning? Let's see if your computers, let's see, here is OS, here is one process, here is also some spaces, here is also one process P2. So does this process P1 can directly access the process P2? Any data if it is required from this process P2, does it from here can it actually directly access the other process P2? Actually it cannot access that directly to other process. Okay. Also when you create a process, from your computers by using from your applications or your programs, when you open any process, for example MS Word, and then let's say Photoshop, and also another PPT, PowerPoint. Okay, PowerPoint. When you open any software or any process, it creates it creates a new process. Okay, it's create a new process, and this process actually move to the computer's memory. Okay, so from this also this when you create a new process or when you run any programs in your computers, it's also create a one process. When you run a code from C code inside your computers, C programs code, it is also a process. Also, it should be inside the RAM or memory during the execution time. Okay, this process, it has some special name. It's called the user process. Okay, user process. Here is it's known as the user process. Also, another process is called the system process. Your operating system is also a system process. Example of system process. There are two types of process. So two types of process. One is user process, another is system process. When you create your own process, when you actually open any programs or any applications, it creates the process. This is the user process. And example of system process is operating system. Okay, this is the example of system process. And when you when your process during the execution time, let's say process P1, it is user process. When it needs any data or any IO devices data, let's say you write a program also. Also here is also in C program or C, you use the C in coda. C in. This is C in to take the input from keyboard. Or some you may write some mouse program to take this data from this mouse, and also either you can either you can read a file from HDD as well. HDD. Okay, this is IO devices. If your programs need to access any IO devices, that time it needs to actually call call a function from OS. This process actually cannot directly actually call directly. When actually call these cin functions, then eventually you call some function. It will actually call some functionality in OS that is related to keyboard, and from there actually from there it can access the keyboard data. That actually I'd like to mention in here that when there is when you need to get data from any IO devices, it can be a hard SSD, hard disk, it can be keyboard, it can be mouse, any data from anywhere, it needs to call some function inside the kernel. This is called the actually system call, or this is actually when you call any function from a kernel, it's referred as a system call. Okay, so when you access data from any IO devices, it needs to make a system call and to perform the data, to receive the data, or to make this output of the data. Output data means that if you print any document, also here also need a one system call, that some function inside the operating systems kernel. This is called the system calls, and this mode of operation is known as the kernel mode of operations. Okay. Okay, so when you call it, when you call a operating system for to print a key, data in your printer, some printer you try to print the data for a printer. So what your process will do? Process will call some function, a printer routine from operating systems, and that time this operating system function will execute to print the data from the printer. So this time your actually process is now working. Your process is called one function that is inside the operating system kernel, and this time actually it's print some data into the printer. It is known as the kernel mode of operations. Okay, when it's called the system, when it's called any systems call, then actually it's switched back to a kernel mode of operations instead of user mode of operation. Means that when you open your systems, at the time that when you let's say you open your computers here. So first your operating system needs to load inside the RAM. So of course here is should be one system call. system call or kernel mode of operations. When it's system call, it also open a kernel mode operation. When you create a new process, it is user mode operation. When you open a new application, this is user mode operations. User mode operations. When you actually open user mode operation means that you create a new process. When your process need any data from keyboard, this is also system call. That times it switches to kernel mode of operations. Kernel mode of operations, and then again it's read the data from, let's say, from keyboards, and again switch back to user mode. And then your process may need to print the data, then again it switches back to kernel mode of operations. So a process is always kind of, we can say, it's a kind of switch between the kernel mode as well as the user mode of operations. Okay, any questions or comments? Okay, so let's move forward to another topics. So another thing is that in kernel, when OS can execute only user programs in user mode of operations. You know already from this name you can understand that when you create a new process, that time it can actually this process it can execute as a user program can executes in user mode operation, and kernel mode operation always execute the kernel program, any kernel programs. Okay, when it switches back to the kernel mode, it's execute, of course. It's when it switches back to the kernel mode, OS is execute a program from its kernel, operating system kernel. Okay, not the program that you write. Okay, so when you use the cin, let's say when you use the cin in your programs, use actually cin, but it is kind of at the behind scene, it's actually called a one function at the operating system kernel. So that time it executes some functions from this kernel. So OS actually this time OS executes only some function from this kernel, from the kernel of operating systems, not from your process, not from your user process. Okay. Okay, let's see another concept is called, now what we learned so far. We learned so far what is the kernel of operating systems, and what is user mode and kernel mode operations. And next, see what is the context switching or mode switching. We already know about this mode switching. When you write a programs, when you execute a program, it's always switch between user mode to kernel mode, okay, during the execution time. Okay, so this is called the mode switching. You on this computer system call, load the operating system inside the OS, you open a new programs or MS Word program, let's say, and then it is currently is now user mode. When you type, it's actually switch to the kernel mode, and then actually it takes the data, and then actually it's back to again user mode, again you type, and then again actually back to the kernel mode of operation. So it's all a switch between actually one mode to another mode. So this is called the mode switching. Okay, another thing is called the context switching. What is the context switching? Okay, so we know about what learn the what is two type of things here. One is called context switching, and another is mode switching. What is the concept for this context switching and mode switching? We already know about this mode switching. Mode switching between the kernel program to user programs is called the mode switching. But for context switching, it means that you let's say this is your CPU, and inside your RAM, here is OS. Let's say here is some processes inside the memory. Okay, from here, you see, from here, if it is, let's say currently your process P1 is executed by the CPU, and then P3 actually comes from your disks to RAM, and P2's and its priority is higher than P1. So what's your operating system will do? Your operating system will schedule the schedule for process P2, and P1 will be preempted. P1 will be preempted. Preempted means that forcefully your CPU stop this process, and then it will schedule the process P2. Okay. You will execute from here. You can see that you just switch between one user process to another user process. Okay, you switch between one user process to another user process. Let's say again P3 comes, its priority is higher than the process P2, currently P2. Then P2 will be preempted, and operating system will execute the process, switch to process P3. Okay. Currently your CPU is execute the process P3, is executing the process P3. Again P3, if when the execution is done by the CPU, then P3 will be actually terminate from OS, from the RAM, and then from here one process will get the CPU to complete its execution. So from here you can see that always with your operating system switch from one process to another process. Okay, this is user process, one user process to another user process. When the switch between one process to another process, it is called the context switching. So you know the mode switching as well as the context switching. When switch between the one user process to another user process is called the context switching. When switch between the kernel program to user programs, it's called the mode switching. Okay, this is the some very important concept for process, as well as when we talk about the process and thread. These are very important concept. We frequently use this term, the context switching, mode switching, and also operating system kernel, user mode, kernel mode of operation. Okay. Next, see that what is the state of a process. Okay. And next topic is, currently we are exploring the process, not thread. Let's see the what is the states of a can be a particular process. Okay. From here, you can see that when a process comes to the memory, what it can do? It can be either it can be executed by the CPU, or for example, if the new process arrive, then what's happened? If a new process arrives and its priority is higher than process P1, then what it will do? Process P1 will be preempted, and it should be wait inside the memory, and higher priority process will be executed by the CPU. So from here, either process can execute execution, actually process perform the executions, or it can waiting waiting phase, or a process when actually a process needs some IO events. When a process needs some input from this IO device or output for this IO device, we call it IO events. Process actually process mode actually changes to the IO. Performing process actually goes for performing IO, input output, okay, or it can be IO modes, okay, input output modes. Okay, these are the three major things actually performed by a one process. From here you can understand that there is three processes. There is three processes, P1, P3, and P2. Let's say P3 comes to the RAM and there was no process, and P1 is currently executing by the CPU. So it can be in execution mode, and then P3 comes to the RAM and its priority is higher than P1. So P1 will be preempted by CPU, and P3 will be executed by the CPU, and P1 state is now waiting. Okay, it can be waiting, or P1 and P3, let's say, executing currently right now, but it needs to take input from your keyboard or mouse. So it actually needs to currently it is now in IO state or IO mode. Okay, IO mode. It is waiting for the IO event, any IO event or any it's currently performing the IO. It's either it cannot actually a process cannot execute further until actually fulfill the IO mode or IO state. Okay, so these are the three these are the three modes, you can say. This is not a state, but it is a part of a state as well. Okay, we'll see the different state of a process in next. Okay, do you have any questions or comment regarding the state? This is the mode, process mode. Now we'll talk about the different state of a process. Okay, now our topic is what is the different state for a particular process. Okay, when you create a new process, state, let's say, states of a process. When you create a new process, it is, you know, that it is always inside the when you open a new process, it is inside a as hard disk, SSD. It is inside the hard disk. This is a process P1. So when you create, it is called the new state. This is called the new state of a process. New state of a process, just created a process. When you create it, this is called the new state of a process. Next state is called the ready state. What is the ready state? Ready state means that you get the, let's say, P2, P3, three programs you are trying to open, you are currently opens, and then three programs are now inside the memory. Okay, inside your computer's RAM. Okay, P1, P2, and P3. Okay, these three programs is now currently actually scheduled by your operating systems to CPU for execution. So this all process is now currently ready state. It is ready to execute. Okay, this is called actually known as the ready state of a process. This process is not actually currently is in execution mode or not performing the IO. It is just waiting in here, waiting for executions. It is ready for to execute. So this is called the ready state, but it is not in an execution mode. Execution or running mode is different. Okay, so this is called the ready state. It is ready currently right now for to execute by the CPU. Okay. Next state is called Then your scheduler. Then your scheduler. What is who is scheduler here is short-term scheduler. Huh? Usually short-term scheduler. Actually, it's scheduler process to CPU to run. So this time it is called the running state or execution state. Okay, this is called RUN, run state. Okay, running state. Ready state. From this ready state, a process can go to the running state. Okay, a scheduler schedule a process for running state. Okay, from this running state, what it can do? It can let's say process P1. At first, let me clear in here some part. Let's say process P1 first comes to the RAM. You know already. First comes to the RAM and it is scheduled by the CPU. And then process P2. Currently, P1 is now running state. And then process P2 comes into the RAM and its priority is higher than the process P1. So what your operating system will do? Operating system will schedule for the process P2, to execute by the CPU, and process P1 will be preempted, and it will back to the RAM. Okay, it will back to the RAM, and then so from here you can see from this running state, a process can back to the ready state. Okay, for example, here higher priority process comes into the RAM. So this process is now stop execution, and then process P2 is now currently executing by the CPU. So this process is now currently ready state. It backs to the memory. So it is now in ready state. So from here, running state depends on the priority. Let's say, depending on process priority. Depending on process priority, a process actually from this running state, a process can backs to the ready state. Okay. Next is another from this running state, a process can actually moves to the terminated state. Terminated state when it is completion. When it is completion, okay. When it completes its running, as you know that when it's let's say process P2 is now currently completes its tasks or running, then what's actually your OS will do? We will erase or terminate this process from the memory. Okay, from the memory. So it is it's done by the execution. So this process will be terminated. Okay. So from this running state, one state could be the completion. Then process will be terminated. This is called the terminated state of a process. And then another thing is there. There are several things steps also available. From this running state, you know that a process, your process may ask for, let's say P1 is currently running and it asks for some data from keyboards or mouse, or it may print some data to your printer. So it is now currently in IO state, where it's read the data from IO devices, or when read the data from the IO devices as well as the HDD is fine. Okay, so this is known as this is called the IO state. Okay, from this, so from here you can see from this running state, a process can go to the IO state. Okay, if it is request for IO request, then a process can actually goes to the process goes to now currently IO state. Okay, currently IO state. So when a process performing the IO, that time that time actually your CPU cannot actually run this process. Okay, when it is actually goes when a process goes to a IO state, your CPU cannot perform this execution of this process until its IO state completes. Okay, IO state completes. Your CPU cannot execute. It is actually you can, if you think about it, you can think that actually it is not possible. When you run a program, let's say your program needs two inputs. So until you actually provide this input, it is now in IO state. It is now in IO state to take the input from your keyboard. So until you provide this input, your CPU actually nothing to do over there. So when for further execution, okay. So when a process is performed the IO, then that time actually this process your CPU cannot execute the process further until it's completed the IO. Okay, so this state is also known as the block state. Okay, block state. Until performing the IO, it should be the block. Okay, this process should be the block. Okay, this is called the block state, IO state, and then if it is perform this IO, if it is perform the IO, when it is complete the IO state, then what it can do? It can back to actually two way. When it is complete the IO, it's again go for the ready state. It can be when it is complete the IO, it backs to the ready state. Okay, ready state. Because when it's performing this IOs, let's say P1 is now is currently performing the IO. Okay, currently performing the IO. Here is another process. Let's say P2. Let's say P3. Okay, just for your understanding, here is another process is now called the P3 is now inside the memory, and currently P1 is currently performing the IO. So your CPU cannot further executes until it's finished the IO. So what your CPU do? CPU will schedule your, not actually everything scheduling, everything is done by your operating system. So your operating system will schedule the process P3 to CPU, because P1 is currently in IO state. It cannot execute by the CPU until it complete the IO state. Okay. So it's currently your operating system actually schedule for process P3 to CPU for execution. But even though in here, even though P3's priority is less than P1, but your operating system will schedule for this process P3, because P1 is IO state. So CPU is now free. So P3 will get the CPU for execution. Okay. So in IO state, a process can automatically back to the ready state. Okay, until it's when it's complete the IO process is IO completion, then it is now in ready state. Okay, your process when it needs any IO, then it's performing the IO, and by this time your operating system will schedule another process for execution, because your operating system cannot schedule the process P1 until it's performed the IO, complete the IO. So it backs to the RAM, and when it's complete the IO, now it is ready state. Your P1 is ready state. Okay, your P1 is ready state because it's complete the IO. So it is now currently in ready state, and next your OS can schedule the process P1 because it is now in ready state. It complete the IO. So after this IO state, a process can backs to the ready state for execution. Okay. Next another thing can happen here. One is for suspend suspend IO. One is called suspend IO, suspended IO or suspend block. Suspend IO, suspend IO state. From IO state, it can go for suspend IO, or it can also moves to resume. Resume. When it's happened, suspend IO is happen. Suspend IO is happen. Okay, so suspend IO is happen when a higher priority process comes into the RAM. Then what's it will do? Let's say process P1 is now currently IO state. Process P1 is currently IO state. Process P. Okay, so let's say process P1 is currently IO state. So here is some other process trying to actually comes into the RAM. So that time what it will do? It will do the this process. This process P1 is now in IO state. So your operating system can swap out this P1 in to the hard disk SSD. Okay, to the hard disk SSD, it can swap out. When during the IO state, a process actually needn't reside inside the RAM. Even it is inside the SSD, it can performing the IO. Okay, performing the IO. So this is called the suspend IO state. And when it is performing the IO, completing the performing, it actually resume. When actually some lower priority process, then it is suspend the IO. It means that this process actually now backs to your disk, backs to your SSD or hard disk. Process P1 backs to your hard disk, and here some other process actually comes into the RAM. Okay, even though this process is P1 is currently in IO state, also it is inside the SSD, but still it can perform the IO. During the IO times, a process actually shouldn't reside inside the RAM. Okay, inside the RAM, it shouldn't. Even though if it is resides inside the hard disk, it can perform the IO. When it is back, process P1 come back to the SSD, it is known as the suspended IO state. When it is done, it is let's say after the suspended IO, let's say one process P4 actually schedule, and then it's perform the execution, and then process P1 actually back to the again memory or RAM. Process P1 again here back here, actually here is another process, and then process P1 again come back to your computer's memory in here. But still during the when it was in SSD, when it was in disk, still it may not complete the IO. It may complete, let's say when it is here, it was trying to complete the IO, but it complete, let's say 20%. After 20%, some process actually trying to comes to the RAM, and then your OS actually this process moves to the disk, and here another process P4 comes in here, and then what it does, let's say during this SSD, your process actually complete the 50% of IO. Now another 50% actually is still remaining. So, and then again this process P1 gets the slot to moves to or comes to the memory or RAM. Now still 50% is remaining. So this is called the resume. It can resume another 50%, process can complete in here. So during here, when it was in here, it completed 10%, let's say, here when it was back to the disks, it's complete 40%, and again it get actually chance to take a slot from the memory. That time it's complete 50% of IO, and the 50% is remaining. So now it will complete in here 50% of IO time. So this is called the resume state. It can resume the IO state inside the memory again. Okay. So this is suspend. Suspend actually nothing but this process actually moves to RAM, moves to memory to disks. Okay. Even though process moves memory to disks, but in case of IO state, it is IO actually it is continue. It can perform the IO state. The process shouldn't. This is a very important point. You may take a note. The process shouldn't actually need to inside the memory or RAM during the IO state. Okay. Okay. These are the two things. Suspended IO. Okay. Here, let me clear some part so that you can understand. Here it's suspended. Suspended IO. Here is resume. Okay. This is for IO state. And another thing from this IO, another thing can happen. What is this one? Let's say it's complete the IO. It's complete the IO, but still in suspended. Let's say here I'll tell you that resume. Resume means that here it gets the during the IO time, it gets again slot inside the RAM. Okay, inside the RAM, so it can resume inside. It can resume the IO state inside the RAM. It is called resume, and the block is still in IO state block. It can move. Suspended means the block is your process is inside the disks. So from the suspended state means the your process is inside the disks, but it completes the IO when actually it's inside the disks. Maybe let's say when it is 10%, when the process was completed 10% of IO, that time it's back to right back to the disks, and then it was waiting in here inside the disks, and then it's perform the 100% of IO when it was actually inside the SSD or hard disks. Okay, so from here it can so it now it doesn't require to resume. It doesn't require to resume IO state because it's complete the IO state already. Okay, so what it's from what it can what is the state from here? Let's say here it's process completed IO, but still in suspended. Process complete IO, but still in suspended. But still in suspended. Let me write it in here. But still in suspended. If it is the case, then it should move to another state. Okay, it should move in still in suspended. Process complete the IO, but still it is in suspended. Suspended means still it is in inside the hard disk. Okay, suspended. Then it actually moves to another state called process state called the suspended ready state. Suspended ready. Suspended ready comes to later. What is the suspended ready state? Okay, so this is suspended ready state. What is a suspended ready state? A process from this ready state you can understand that what is the suspended ready. Okay, from here when the process is created, it is in ready state. Okay, it is in ready state. Let me clear in here some part. Let me clear some part in here. Okay. Okay. In here. Okay. Let me. This is resume. Okay. Let me clear so that you can understand clearly. This is suspended. Here is from the suspended IO, it can resume IO inside the RAM, and then it can suspend IO complete, but still in suspended, but still in suspended, means that process complete the IO, but still it is inside the DEX. That time, from this IO state, a process can jump into suspended ready state. Now let's see what is the suspended ready state. Okay, what is the suspended ready state? Let's say you have total here also DEX, here have P1, P2, P3, 3 process, or let's say P4, 5 process inside the DEX. Also here is your RAM. Also here is how many process? P1, P2, P3, P4. All are ready state because all are inside the RAM. All are inside the RAM. So this is the this process is all are inside the ready state. Okay, all are inside the ready state. But in this time, process P4, you open another process, is called the process P5. Okay, P5 comes open. Also, let's make an assumption that process P5 is priority is higher than all other process. Let's say all other process means let's say process P1. So what your operating system will do? Operating system will do actually write back this process inside this DEX, inside the DEX P1, and then this slot, this actually memory will be allocated for process P5. Okay, process P5. So now operating P1 process inside the DEX, it is not inside the RAM. So if it is inside the RAM, then we can say it is ready state. But when it's backs to the memory, backs to the DEX, then it is not in a ready state. This is called the suspended ready state. Actually, suspended ready state means when it gets when it gets the opportunity or any chance to get the slot inside the RAM, it will again backs to the ready state. Okay. So now when a new priority process comes to the RAM, then one ready process may actually go for the suspended ready state. Okay, so it can be suspended. So from this ready state, for our example, process P1 was in here ready state, but it is now suspended for new higher priority of process. So from this, so from here you can understand from this ready state, a process can suspended. From this ready state, a process can suspended. Is suspended to suspended ready state. Okay, suspended ready state from means that from this process actually moves to the DEX from the RAM. Okay, this is called suspended ready state. And then again, let's say P5 completes its execution, then again your operating system will schedule can actually allocate the memory for process P1. Let's say again it's execution memory for process P1 in here. Process P5 completes the execution, so it is now terminated. So process P1 is now here, means that it is now in ready. So suspended ready to, it may moves to again resume to ready state. Okay, resume to ready state. Okay, so from here you can see the suspended IO. Suspended IO means that it is in IO state inside the DEX. Let's say process P6 inside the DEX. It was in suspended IO. Also, it completes the IO inside the when it was inside the DEX. So it is not currently. It's not in an IO state. It completes the IO. Okay, it doesn't require to resume in here because it's already completed the IO already. Okay, so it is not in an IO state. So from this, if it is inside the DEX, so it is better to backs to suspended ready. Now it is let's say from this IO2, it may backs to suspended IO, suspended ready. because it's complete the IO. So when it gets the actually memory inside the RAM, then again back to the ready state. Okay. So from this suspended IO, when it's complete the IO, but still it is suspended. So you can this process can backs to the suspended ready state because it is better state than the suspended IO. Okay. Okay, that's from here you can see that process, when process complete the IO but is still in suspended, means that it's still inside the disk. So you may back your operating system may back to this process in suspended ready state. When it get the opportunity, then it will resume to ready state. Okay. So these are the major state or major statement. These are the state of a process. Okay. When you create a process, it can be ready, run, terminate, or it can be moves to the IO state. It can be go suspended IO state, means that when higher priority process comes, means that it actually backs to the suspended IO state. Okay. And then suspended ready state means that also higher priority process comes to the RAM, so it is suspended ready state. Okay. And then from the suspended to it can resume. Always it can be resume. Okay. When it's enough memory is available inside the RAM. Okay. So this is the state of process. This is actually beginning of our process for understanding the process and thread, these chapters. Now we are continuing with the process. In next, we'll see some process control block, means that what is the actually ingredients usually a process contains. Okay. Then we'll talk about some attributes of process, and next we'll go for this some CPU scheduling algorithms. We already know about some memory allocation algorithms. Here also some algorithm for the CPU scheduling algorithms. We'll actually elaborate and explain. We'll see the CPU scheduling as algorithms in our next or some upcoming class. Okay. So today we are almost running out of time. If you have any questions or comment regarding today's class or your exams. Okay, if no, let me stop my recording.